Hello, I am Ian Dichosa from the Peer Tutor Society, and I am here to talk to you about recurrence relations in data structures and algorithms. So before we could understand what are recurrence relations in data structures and algorithms, we first have to examine yung mga dati nating lectures on previous courses. So if maalala mo pa, in CCDS2 or discrete structures, we learned about recurrence relations through summations and sequences, diba? So it says here that a sequence is defined using the previous term in the sequence. So my example ako ditong recurrence relation. It says here a sub n is equals to 3 times a sub n minus 1 minus 3, where n has to be greater than 1. Is because nga if n is not greater than 1, then there's possibility na magkaroon tayo ng a of 0 minus 1, a of negative 1, which doesn't make any sense, di ba? Given that, we also need yung starting condition. The starting term or starting condition natin here is the a sub 0, which is equal to 4. So if a sub 0 is equals to 4, we can find all of the other values inside the sequence. So a sub 1 would then be equal to 3 times 4, which is 12, minus 3, which is 9. A sub 2, which is 9 times 3, 27, minus 3, which is 24, and so on and so forth. So we also have to remember CCPROG2, wherein we learned about recursive functions. So recursive functions are functions which call itself. May two parts siya. Here, the first part is the ending condition. If n equals 0, then it would return 1. So this factorial function here, it would actually compute for the factorial of a number. The factorial of a number is yung exclamation point, if you ever seen that, where 5 exclamation point, that would then be equal to 5 times 4 times 3 times 2 times 1. Parang ganun. So if n is not equal to 0, it would return n times factorial n minus 1. And what would happen here is that it would go through the functions and it would see, oh, factorial. So let's run it again. So if I run it again, then it would check, is it equal to 0? If not, run n times factorial n minus 1. So for example, what would happen here for n factorial of 2, it would run 2 times n factorial n minus 1. Makikita niya 1. So 1 times n factorial 1 minus 1. So it would be 0. So it would be 2 times 1 times 1, which is equals to 2. And that's how recursive functions generally work. Now we are going to combine those two concepts. We are going to make an algorithm here. And using what we know in CCPROG2, we can understand and trace how the algorithm works. Tapos naman in CCDS2, we are going to use that to compute for the time function of the algorithm. Okay? So we have two main methods of doing this. First is the recursion tree, and second is the substitution method. The substitution method, first, we need to translate the algorithm into a time function, but both of these two methods will give us the closed form of a function, of a time function. If alala nyo pa yung closed form, ano yon? If you would remember CCDS2, a closed form would imply you converting a recursive relation into a non-recursive form. Hindi na siya nagre-rely dun sa previous terms ng sequence. However, it would still give out the same outputs. So try natin yun. If titingnan natin itong example algorithm natin dito. And let's just trace and get the time function. Yung simple lang. Like how we would normally get the time function. So if you remember here, the t of n would then be equal to just a 1 here for the if statement. And the time complexity or the time unit for this. Ano yung time unit ito? As you can see here, the time unit of this actually depends on t of n. So we can actually say it's t of n minus 1 because it's defining, it's defined by the function itself. It is recursive call. Therefore, we could just say t of n minus 1. And just like that, when we add those together, you get t of n equals to t of n minus 1 plus 1. So that is our recursive call. That is what happens when n is greater than 0. Well, what would happen if n is less than or equal to 0? Baliktad naman. If n is less than or equal to 0, sabihin natin yan, then only this one would run and not these, right? So just to further clarify on the time function, it's not actually this, it's just one part of this. It's just one part of the whole time function. The whole time function would actually look like a piecewise function. May two pieces siya. One, if the value in the if statement is false, so n less than equal to 0, or t of n minus 1 plus 1 if n is greater than 0. Okay? Now that we have that, we can compute, we can solve for the closed form. Why is it important to solve for the closed form? Well, if you would try to compute for the time function, given value n, let's say if n equals 2, what would we do? We would input 2 here, t of 2, it is greater than 0, so it's equal to t of 2 minus 1 plus 1. Then it would actually become t of 1 plus 1. Now what is t of 1? T of 1 here is t of 0 plus 1 plus 1 from the previous equality. Now t of 0 here would then be equal to 1 plus 1 plus 1 is equal to 3. Now this is easy and all, tracing this. However, what if we would do t of 50? Then you would need to write it out 50 times. The t of 100, you would need to do 100 times. And that's just inefficient, diba? We don't want to do that. Instead, it's way better if we would just use the closed form, input the n there, and get it done, get it over with. So we have two methods for doing such. We are going to use recursion 3, recursion. So we have two methods. So we have two methods of doing so. The first one I'll show you, which is the recursive 3 method. Recursive 3 method. So here we are actually going to trace the behavior of the function. So let's say if n is greater than 0. N is greater than 0. T of n would give out two parts, t of n minus 1 and plus a 1. So let's just separate those in a 3-man in this kind of tree structure para mas maganda natin siya makita. Now, what would t of n minus 1 give? It would give out a 1 plus t of n minus 2. T of n minus 2 would give out a 1 and t of n minus 3, right? So if we continued on and on and on for this until we reach some number, t of n minus some number x, sabihin natin x, what would it give? Yun yung tanong. We are trying to look for the pattern here. So the pattern here if we would observe, itong 3 na ito, that's how many number of times we see a 1 here, right? So we could say that this is 4 times, and we would get 3 times here. Parang ganon. So for the whole function, let's say it looped x amount of times. Therefore, ito ay x times ito, you would also get, sorry about that. So if we say that it looped an x amount of times, we would get an x amount of ones here, right? That means we have x plus 1 t of n's, parang ganon. Okay? So when does it stop? When does the looping stop? Well, the looping stops if we check here, if n, the value inside, is less than or equal to 0. So that means in the same manner here, if this inside here is equals to 0, the loop will stop. Okay? So let's put that algebraically. N of x equals to 0. If n minus x equals to 0, the loop will stop, and yun na. We finish the call. Transposing it to the other side, we get n equals x. That means we would get an n plus 1 amount of t of n's here, and an n amount of 1's here. So magiging n times 1. Now, as we can see here, t of n minus x will become t n minus n, which is t of 0. And what is t of 0? T of 0 here is 1. So this would give out a 1. Now we just add up both components together. We have an n times 1 here and a 1 here. So that means our t of n is equal to n plus 1. And that is just our closed form. So di ba mas madali na? You don't have to do the recursive calls over and over again. You just input the formula. Try natin dito, t of 50. That means t of 50 equals to 50 plus 1, which is 51. T of 100 is equals to 101. Yun na, right? Incredibly easy. Now, let's try out the second method, which is the substitution method. Okay? Now, keep in mind, both of these methods, they both should land you on the same answer, okay? So if you're having trouble with this and you're not too sure, you can always try the recursive tree method to check, diba? So let's say we have n is greater than 0. If n is greater than 0, then t of n is equals to t of n minus 1 plus 1. Now, what is t of n minus 1? T of n minus 1, if we substitute it inside, we would get t of n minus 2 plus 1 plus 1, right? According to the definition here. If we substitute it one more time, we would get t of n minus 3 plus 1 plus 1 plus 1. Okay? Now we start to see a pattern. The number here, the 3, is equals to the number of ones on the outside as well. So if we would say t of n is equals to t of n minus x, then the number on the outside would also be an x. Tapos we ask again, katulad dito sa recursive tree, when does it stop? it stops when the value on the inside is less than or equal to 0. So the closest number that we have is 0. So it stops at this point. So that means n equals x. And we get t of n is equals to t of n minus n plus n, t of 0 plus n. And if we would check what's t of 0 is equals to 1. So we would get n plus 1, which is the same time function. Okay? Now, I would show you a bit more different examples. Let's try it out. So here I have a different function naman. Instead of just doing nothing but the recursive call, it has a for loop inside. Yun yung pagkakaiba. So let's construct the time function as normal. T of n, this would give out a 1. These two, it's a for loop. If you would remember, it would give out n minus 0 plus 1 plus 1. The statement inside would be n minus 0 plus 1. Finally, the hello function, it is the recursive call. It would be t of n minus 1. So that would mean our function would be t of n is equals to t of n minus 1 plus 2n. Wala na to, 1, 2, 3, 4 plus 2n plus 4. Okay? Let's try it out with the recursive tree method. Recursive tree. So we would have t of n if n is greater than 0. For that pala, we need to construct the whole function, right? So n is less than or equal to 0, then it just output a 1. Therefore, the whole function should be t of n is equals to 1 if n is less than or equal to 0, or t of n minus 1 plus 2n plus 4 if n is greater than 0. Okay? Now, let's try out the recursive tree. So t of n would give out two parts. Ito, the non-recursive part. We'll take a non-recursive part. And here, we would call this the recursive part. So using the recursive tree, we would separate it into those two parts. So my t of n plus 4 here, then t of n minus 1. Continuing on, this would give out t of n minus 1 plus 4 and t of n minus 2. Let's do it again. T of n minus 2 plus 4, and this would give out t of n minus 3. Okay? If we would continue this all the way, we would eventually reach numbers like t of 1. So for t of 1, it would give out 2 times 1 plus 4. And eventually it would reach t of 0, which is 1. Now, what do you notice here? This is a different way naman of solving recursive trees, no? Kaiba naman siya. Because, let's talk about how many times this loops first. This loops from 1 to n, right? So that means from 1 to n, we are inputting some value, and we are doing 2 times some value plus 4. If you would remember sa CCDS through, that's exactly the definition of a summation, right? It's very similar to a summation. So we can actually just represent it as such. Ano ba yung summation ito? Well, it would be 2 times some number k plus 4. Going from k equals 1 all the way to n, right? If we would try to expand this, we will get 2 times 1 plus 4 plus 2 times 2 plus 4, all the way to 2 times n minus 1 plus 4 plus 2n plus 4, right? So, using our background knowledge sa CCDS2, anong pwede natin gawin? Ang pwede natin gawin ay hanapin ang, ano ba to? Ang closed form nitong summation. Closed form. Okay? Because currently, what we can see is that our t of n is equals to that summation, 2k plus 4, all the way to n, plus 1. Yun lang. So we just need to find what is the closed form. We can do that pretty easily if you would remember see this through. First, what we would do is we would distribute the summation function to both of these terms. We'll get 2k, k equals 1 to n, plus k equals 1 to n of 4 plus 1. Now, next part. This one, I could factor out the 2 out the outside. You would get 2 times k equals 1 to n, plus k equals 1 to n, 4 plus 1. Now ito, pag naalala nyo pa, what is the closed form of this specific type of notation? It would be 2, tapos yung upper bound, 2 here is yung nasa labas. Tapos yung upper bound n times n plus 1 all over 2. We do the same thing here sa ito namang term. If you still remember yung closed form niya, it would be 4 times yung upper bound minus lower bound 1 plus 1. And plus 1 sa dulo. Now we just simplify everything, cancel that, cancel those, distribute that. It would get, distribute these, get 2n squared plus n plus 4n plus 1, which is equals to n squared plus 5n plus 1. Whew, diba? But, well, for me, I really like the recursive tree, but yung personal na ginagamit ko is yung substitution method. So let's try it out on another example, yung substitution method. So here we have a function naman. Now instead of decrementing by 1, we are decrementing by 3. Iba naman yung pag-minus natin. Let's solve it as usual. Let's look for the closed form. The time function pala, just the time function in general. So this would give 1, this would give 1, and this would give t of n. Hindi pala n kasi yung x yun. X to dapat. T of x minus 3. That means t of x is equals to t of x minus 3 plus 2. That is in the case that x is greater than 0. If x is less than or equal to 0, then it would just input a 1, output a 1. Therefore, the complete time function would be 1 if x is less than or equal to 0, or t of x minus 3 plus 2 if x is greater than 0. So now, let us perform the substitution method. So I would first say if n is greater than 0, not n pala. We are using x. We have to be mindful of the variables written here. If x is greater than 0, you would say t of x is t of x minus 3 plus 2. Now, what is t of x minus 3? Solving it, we would get t of x minus 3 plus 2 plus 2, which is also equals to t of x minus 6 plus 4, right? Furthermore, what is t of x minus 6? It would be x minus 9 plus 6. What is t of x minus 9? It would be t of x minus 12 plus 2 plus 6, which is equals to 8. T of x minus 15 plus 10 kapag further expand pa natin siya. So here, nakikita na natin yung pattern. Let's factor out a 5 from both of these. So we would be left with t of x 3 times 5, yung nasa loob, plus 2 times 5. Same value, right? So may 5 dito, may 5 dito. Dito naman, it would be 3 times 4. And this 8 would be 2 times 4, right? Here, it would be 3 times 3. 6 is 2 times 3. Here, it would be 3 times 2. And 4 be 2 times 2. So here, we can start to observe the pattern, right? In general, if we have some number, t of x minus, let's say, 3, let's say, 3 times k, parang ganyan, yun yung form niya. Then, on the outside, we would have 2 plus 2 times k, right? Now, the question here is, when does the recursion end? The recursion ends when the value on the inside is equals or less than 0. So, if x minus 3k equals to 0, we can solve for k. So that means x is equals to 3k, k is equals to x. So let's solve plus 2x over 3. This would simplify, cancel these out. We would get t of x minus x plus 2x over 3, t of 0 plus 2x over 3. And what is t of 0? T of 0 is equals to 1. So we would get t of n is equals to 2x over 3 plus 1. And that is our time function, our closed form. Okay? Lastly, let's try one last example. However, instead of decrementing, this function here will be dividing. Iba naman, dividing naman siya. Same methods pa din try natin. I'm going to use the substitution method. Personally, I think it's more efficient. Once you get the hang of it, mas mabilis siya gawin, mas madali. But it's up to you what method you want to use. So t of n here, the time function, this would have a time unit of 1. This would have 1. This would be the recursive call, which is t of n over 2. That means our t of n is equals to t of n over 2 plus 2 if k is greater than 1. If k is less than or equal to, not 0, but 1, then it would just give out a 1. Additionally, we should be mindful of the variables here. It is not an n, rather that should be a k corresponding to the k here. So our complete time function, t of k, is going to be equal to 1 if k is less than or equal to 1, and t of k over 2 plus 2 if k is greater than 1. Now let's perform the substitution method. Substitution method. Okay, So if k is greater than 1, we could say t of k is equals to t of k over 2 plus 2. Now what is t of k over 2? That is t over k over 2 over 2 plus 2, then we add the other 2. And this would just simplify to tk over 4 plus 4. Now, once you get this, iisipin mo, ito na ba, n lang to, tas n lang to? No. You have to keep on continuing on and try to find other values. If we continue on to find the pattern, we would see na this would become t of k over 8 plus 6, t of k over 16, 16 to, plus 8, tk over 32 plus 10. Now, ito na yung pattern niya. If you would see, 32 is 2 to the 5th, and 10 here is 2 times 5. 16 here is 2 to the 4th, and 8 here is 2 times 4. 8 here is 2 to the 3rd, and 6 here is 2 times 3. So in general, you would see that t of k, it would be equal to k divided by 2 times some number. Let's say that some number is x, plus 2 times x. Now, what should be the value inside of this t so that the recursion will stop? It should be less than or equal to 1. So if k over 2 raised to x is equals to 1, then we would see that k is equals to 2 times x, 2 raised to x. If we would apply logarithm base 2 on both sides, we would get log base 2k is equals to x times log base 2 of 2. Then we would just get x is equals to log k. Yung log dito, it is base 2. When we are talking about CCDSALG, data structures and algorithms, mga time complexities, ganon, assume that when people write just the log, it is log base 2, hindi log base 10. Okay? So, we just have to substitute the log k into the values here. So we will, t of k is equals to t 2 divided by log k, 2 raised, k divided by 2 raised to log k plus 2 log k. This will be t of 1 plus 2 log k. T of 1, as we established before, is equal to 1. So we get 2 log k plus 1. And that is our time function. That is our closed form. So thank you everyone for listening. I hope that you've learned something today. I wish you all the best in your studies, especially for this topic, this very long and lengthy and complex topic, which is recurrence relations. So thank you very much, guys.